Welcome everybody. In this video we're going to look at a couple of examples about the use of the exponent rules we did in the previous video. So anyway, the first example is the following. We can look at the following example. I want to emphasize that there are many different ways to do the same problem. So maybe the first way I'm going to do is I'm using the following rule. That we can apply this rule. So now the answer becomes we can take the whole thing here as the a here, and we have to distribute the exponent to the whole thing, which means that we're going to get the following for the first number, 3 to the power of negative 1 to the power of negative 1. And similarly, for the second number, we think of it as b here. So in that case, we need to distribute the exponents here as well. So we get that is 4 to the power 2 as the number to the power negative 1 here. So the next step is we have to use the following rule. That if you are looking at the multiplication this way, the exponent becomes a multiplication with two exponents, and this formula definitely can be applied to both things here. So in that case, we are going to get that is 3 to the power negative 1 as the exponent times negative 1. That's the first number. And then the second number, 4, and the exponent becomes 2 times negative 1 here. So I believe you know how to simplify that. Now it becomes 3 to the power 1 times 4 to the power negative 2. And how to get the final answer? Now this number becomes 3 and times. We have to use the following rule now. That's 4 to the power negative 2 becomes 1 over 4 to the power 2 here. So we get that the final answer here must be 3 over 16. That's the final answer to this problem. Let's try a second problem here. If you look at this problem, the first step to apply is you need to apply the following formula here, because you need to distribute the exponents to both numbers here, and it becomes the following step. So and then from this step here, we can do the following by using the step here, because now both things look exactly the same as the formula here, so we can apply it directly to get the top now becomes the power 2 to the power 6, because 6 is the same as the multiplication of minus 3 and minus 2. And similarly, the bottom becomes 3 to the power, which is the same as the multiplication of negative 2 and negative 2 here, which is 4. So that's essentially the answer to our problem. And the last step is you just have to expand the two numbers, 2 to the power 6 to get 64, and 3 to the power 4 to get 81. So the answer is 64 over 81 here. And now the next thing to do is to try out some problems of algebraic expressions. So please look at the following. Please look at this example. You are asked to simplify the whole expression here, and the way to do it is you need to always look at the similar term together. For example, these two numbers, you can multiply them together first. 2 times 5 is 10. That's the first number. And the second one, you can group the two numbers with the base x together. In this case, you can use the following formula. That if you multiply it like that, it's the same as adding these two exponents. So we get that is the same as x to the power. The exponent becomes 3 plus minus 2. That's exponents for x. And similarly, for the exponents of the base y, we get that is the same as the addition of these two exponents, which means the power, the exponent here should be the same as 2 plus minus 1. So I believe you know how to simplify it here, because it becomes 10 times x, 3 plus minus 2 becomes 1, and y to the power 2 plus minus 1, it becomes 1 again. And that's essentially the answer to this problem. Okay, let's look at the following example. For this problem as a fraction, the first thing to do again, you need to look at the two numbers. Now the first step, you have to do 6 is divided by negative 2. It becomes negative 3 here. So the next step, you need to look at the two numbers with the same base. And in that case, you need to apply the following rule for the exponents. That when you are looking at the division for the same base with different exponents, you need to do the subtractions on the exponents here. So in this case, you get that it becomes x, the base x to the exponents 3 here minus -1. And similarly, for the y here, we have to also do the subtraction of the exponents, which means we get the term y to the exponent 2 minus 4. Again, I believe you know how to simplify that, because now it becomes minus 3 to the exponent for x, it becomes 4, because 4 is the subtraction 3 minus -1 here. And then for the y term, 2 minus 4 as the exponent, it becomes -2 here. So the last step here, you need to simplify this term with the negative exponent. We need to use the following rule. That when you see a negative exponent, you can always write it down as 1 over a to the power n here. So to apply this step, we get that it's minus 3 times x to the power 4, and y to the -2 here. We get that it becomes 1 over y to the power 2, and that's the final answer to this problem. So I hope you can see why and how to apply the whole negative exponent to get this part here. Okay, so let's look at the next example now. Let's look at this problem together. Again, when you see a negative exponent, you need to use the following rule. That you can write it down as a fraction, 1 over a to the power n. So to apply it here, we get that the first term, it becomes 1 over x plus, and the second term, it becomes 1 over y. So now there's a step to do for you to simplify the things inside the bracket here. You have to make a common denominator, and now it becomes y plus x at the top. I hope you know how to do it here. In the case that you cannot simplify the fraction here, please look at the notes on the right side. I did the simplification for you, so you can keep going from this example. So essentially, to simplify this thing further, we have to look at how to simplify a fraction if it has power -1. And the way to do it is you can actually flip the fraction, so it becomes b over a. And you can try to see why it is true. But now I'm just going to tell you that if you use this formula, you get that the answer must be the same as xy over y plus x, because essentially we are flipping the two sides here when you see the exponent -1 here. Okay, so that's the end of this example, and this video I've demonstrated how to use the exponent rule to solve 5 examples. Definitely there are some more complicated examples going on, and please try to do the practice on your own. And that's the end of this video. Thank you everybody.